are looking at question number 17 of EC Set 3 K2016 paper. The logic functionality realized by the circuit shown below is which one of the following options? For concept related to this question, you can refer lecture 24 of week 4 named as Past Transistors in the course Digital IC Design handled by Professor Janakiraman Veeraraghavan of IIT Madras. Briefly, the concept you will need to know is that an NMOS transistor is on when the input on its gate terminal is equal to digital 1. The NMOS transistor is off when the input on its gate terminal is equal to digital 0. Moving on to the solution for this question, let us analyze the circuit shown in the figure. Let us name this transistor as N1 and let us name this transistor as N2. So we see that N1 is controlled by gate input B, N2 transistor is controlled by gate input B bar. At any point in time, only one of the transistors will be on. This is because B bar is the complement of B, and an NMOS transistor is on only when the gate input is equal to digital 1. At any point, either B or B bar will be 1, and therefore either N1 or N2 is going to be on. So now, when B is equal to 0, B bar will be equal to 1. That time, N1 transistor will be off and N2 transistor will be on. This implies the output Y will be the voltage passed by the transistor N2, which is ground voltage. Therefore, the output will be 0. Whenever B is 0, the output will also be 0 because N2 transistor is on and it passes the ground voltage. Now, when B is equal to digital 1, B bar will be equal to digital 0. And that time N1 transistor will be on, N2 transistor will be off. So the N1 transistor will pass A's input as output to Y. Therefore, whatever is provided in input A will be the output at Y. So therefore, when B is 1, when A is equal to 0, Y will also be 0. When B is 1, A is 1, A will be passed on to the output Y and Y will also become 1. Thus, this is the truth table followed, and we see that this is exactly the same truth table as that for AND logic of A and B. Therefore, the logic depicted by the circuit diagram is AND logic, and hence answer D is the correct answer.